Alright kiddos, today we're going to learn how to solve quadratics. At least we're going to start it. There's more than one way to do this because just like with everything, there's always more than one way to get to something or to get an answer. And depending on how your problem is presented, it's going to affect which method you use. But we're going to solve quadratics, and you've solved equations before. You've taken an equation you've solved, you found out what x equaled by doing the opposite operation. You're pretty good at that. So quadratics, if you'll remember, look like this. Y equals ax squared plus bx plus c. That's the standard form. And because of this x squared right here, we can't just solve a quadratic like we solve a linear equation or a regular equation. We have to use different methods. And the first method we're going to talk about is how to solve by factoring. And so I told you before that factoring did not go away, is not going to leave. Something you're going to have to remember. And here it is. It's back. So now we're going to factor to solve some quadratics, but before we do that, let's write a few things down. And so the roots of quadratic equations are also called the solutions. And so when you're asked for the roots, that's the solution to the equation. And you find the roots or the solution by finding out what the x-intercepts are of the related equation. And you'll remember when we did our pink book last week, on the very first page of that pink book, you had a picture of a parabola with a bunch of little call-out boxes, and we filled in those boxes with the words that matched what that part of the parabola was. And at the x-intercepts on that pink box, our little call-out boxes had 4 different words in them because there were 4 words that related to that point on the graph. And so those points, sometimes, remember, they were called x-intercepts because it's where it crosses the x-axis. Sometimes it was also just called a solution. It could also be called a root, and then it was called a zero, and all of those words meant the same thing. So if you were given a question that says find one of those 4 words, they're asking you for the same thing. They want you to find to solve the equation and find out what x equals. So that's what we're looking for. So let's actually solve some, and we're going to solve them by factoring. It's the first method we're going to learn. So we're going to go back to last unit, what we learned before. So we're going to factor these quadratics. X squared minus 3x minus 10. We're going to have to factor this, and I'm sure that y'all are tired of drawing boxes by now, but that's what we're getting ready to do. So we're going to draw our box. X squared goes here, minus 10 goes here, and so what I need are 2 numbers that multiply to make negative 10 that add to make negative 3. And so I need to list out factors of negative 10. Well, 1 and negative 10. Well, when I add those, that doesn't equal what I need it to. So 2 and negative 5. If I add 2 and negative 5, oh, there they are. So I have 2x and negative 5x. And so now we're going to factor. Pull out our GCFs. So for this first row right here, it's x. This is negative 5. This one here is x. And that one's 2. So my 2 solutions are, or my 2 factors are x plus 2 and x minus 5. But you're not done because this whole thing equals 0. And what I need are what x equals. And in this case, because it's a function that has x squared in it, there are going to be 2 answers for x. And here's how I find what they are. My first factor was x plus 2. I'm going to set it equal to 0, and I'm going to solve for x. Well, when I solve for x, I do that by subtracting 2 from both sides, so I get x is negative 2. Then I take my other factor, x minus 5, and set it equal to 0 because this entire equation equals 0. And when I get x by itself, I do that by adding 5, so I get that x equals 5. So my 2 solutions for this quadratic right here are x equals negative 2 and x equals 5. And so you factored it, then you set your factors equal to 0, and you get your answer. So what I want you to do is pause for a second. I want you to factor number 2, find out what the 2 solutions are, come back and check your answer. Okay, so I factored my quadratic, and I got x plus 4 and x plus 9 are my 2 factors right here. And then I set them both equal to 0 and got that x equals negative 4 and x equals negative 9. And so my 2 answers are x equals negative 4 and x equals negative 9. Those are your solutions. I got that by setting my factors equal to 0. So now look at number 3, because number 3 is a little different, which is why I didn't have you do it on your own. You'll notice that this is not written in standard form. It says 6x squared plus 5 equals negative 17x. The first thing you got to do is get that negative 17x to the other side with everything else so it's in standard form. You do that by adding 17x, so you end up with 6x squared plus 17x plus 5 equals 0. And then we will factor that. And so we're going to draw our box. So I have 6x squared and 5 here, and then remember you have to multiply your first number times your last number. When I do 6 times 5, I get 30. So I've got to come up with two numbers that multiply to equal 30 that add to equal 17. 2 and 15, I'm pretty sure those are them. So we're going to plug them in, and we're going to factor.
Either one would have been about right.
Alright, so we're going to factor. I've plugged in everything I need. My greatest common factor here is 2x. Here is 5. That's going to be a 3x, and that's just a 1. So my two factors are 2x plus 5 and 3x plus 1, and it equals 0. Now I'm going to do the same thing that I did with the other ones. I'm going to take each factor and set it equal to 0. They're just a little more difficult to solve, just because they have extra steps. So the first one, 2x plus 5 equals 0. I will subtract 5. So I get 2x equals negative 5, and then I have to divide by 2. So x equals negative 5 over 2, and it is perfectly acceptable to leave that as a fraction. If you don't like the fraction, you can divide and make this negative 2.5. They mean the same thing. I don't care. Now to do the other one, we have 3x plus 1 equals 0. So I'll subtract 1, so I've got 3x equals negative 1, and then I divide both sides by 3, so I get x equals negative 1 over 3. Do not divide that one and make it a decimal, because you cannot graph the number 0.3 repeating. You have to make it a fraction, because 0.3 repeating is irrational, or is a repeating decimal and doesn't have an actual place. You have to make it a fraction. So leave that one alone. So here are your two answers, x equals negative 1/3 and x equals negative 2.5. So that's how we solve by factoring. So now let's talk about working backwards, because sometimes you have the root and we need to find what the quadratic is, so we have to work backwards. So like number 4 here, I know that x equals 4 and x equals 7. So we're going to start with the x equals 4. I need this to equal 0, because when I solved all my problems a minute ago, they all equaled 0. And so I need to make this equal 0, and I do that by subtracting 4 from both sides. So I get x minus 4 equals 0. And then I'm going to do the same thing with the 7. So then I have x equals 7. And to get that to equal 0, I subtract by 7. So I have x minus 7 equals 0. Well, these are my two factors. X minus 4 and x minus 7. To get to the quadratic that I needed to start with, the original problem, now I have to go back 2 units, and I have to remember I have to double distribute. So I have to do this times this, x squared. This times this makes negative 7x. That makes negative 4x. And that makes 28. And then I combine my two terms in the middle, so my quadratic is x squared minus 11x plus 20 equals 0. This is the quadratic that has these two x-intercepts when you graph it. So now let's do number 6 over here. Number 6 has a fraction in it, which is not a big deal. It works the same way, but we'll start with the first one. So I have x equals negative 3. Well, I need it to be 0, so I add 3. So I have x plus 3 equals 0. So that's good. Now the next one, I have x equals 5 halves. And I cannot just subtract 5 halves from both sides and say it equals 0. Because the only way that this happened for me to get this fraction is if it was a problem like this one on number 3. The reason I ended up with a fraction is because I had a number in front of the x and then something added or subtracted, so it was a 2-step equation. I took 2 steps to make that fraction, so we're going to have to take 2 steps to undo that fraction. The first step we're going to do to undo that fraction is get rid of that denominator. And if you remember, to clear a denominator, we multiply by whatever it is. So those 2's cancel, so I have 2x equals 5. Now to make that equal 0, I can subtract my 5, so you have 2x minus 5 equals 0. So here are your two factors, x plus 3 and 2x minus 5. And we're going to do the same thing we did up here, double distribute to get back to the quadratic, so that becomes 2x squared. This becomes minus 5x. That becomes 6x. And this becomes negative 15. Put your two middle numbers together, so you have 2x squared plus 1x minus 15 equals 0. There's your quadratic by working backwards. So the last one, you have Algebra Tiles, and they gave you the polynomial, and they want the solutions to the equation, which means we have to factor it. what I love about Algebra Tiles is they make the box really simple. Okay, so if this is my box, let's just translate it. I have 2x squareds in the first part. I have 3x's here. I have negative 4x's here, and I have negative 6. So just do your GCF. GCF here is x. Here is negative 2. Here is 2x. Here is 3. So my two factors are x minus 2 and 2x plus 3. And if I want the solutions, I take each one of those, set them equal to 0. And so if I do x minus 2 equals 0, that gets x equals 2 because I added 2 to both sides. And then when I do 2x plus 3 equals 0, I subtract 3, so I have 2x equals negative 3. And then when I divide by 2, I get x equals negative 3 halves. So there are your solutions. Last one, I'm going to draw the picture, and then I will let you guys factor and find the solutions. And we'll check it as soon as you come to class tomorrow. So you have a rectangular park that has a length that is 4 meters longer than the width. You got a rectangle. The length is 4 meters longer than the width. We know the area is 96 centimeters. To get the area of any rectangle, its length, 4 plus w, times width, w, equals 96. Well, we have to distribute to make this happen. So you get 4w plus w squared equals 96. So you need to set this equal to 0, factor, put it in standard form, factor it, and then use those factors to find out what the actual length of the park is. So I'm going to let you factor that. Then you can come back in just a second and check your answer. Okay, so I factored this. I got set this equal to 0, and I had w squared plus 4w minus 96 is 0. And then my two factors were w plus 12 and w minus 8. Those were my two numbers. You can draw the box and check it, but there are your factors. And so then I set them both equal to 0, and I got w equals negative 12 and w equals 8. Well, we're looking for the length of a park, which means this negative number can't make any sense because you can't have a negative width. The only one we care about is this one. The width is 8. So to find my length, which is 4 more than the width, I'll plug in that 8. So I get 4 plus 8. So my length is 12 centimeters. That's a little bitty park. I'm just saying, 12 centimeters. But the negative one doesn't matter, so you can cancel it out. We still need to define both of them so that we can look at it, but the positive one is the only one you need because it's the only one that makes sense. So we'll practice this tomorrow. I will see you then.